Good afternoon. Our topic for this presentation is Poison's distribution. It is prepared by me, Kaustav, Jayesh, and Sachin, and our enrollment numbers are given aside our names. So, what is Poison's distribution? Poison distribution is basically limiting of the binomial distribution in which n, the number of trials, becomes very large and p, the probability of the success of the event, is very, very small, as you can see on the chart given on the right side. Now, why do we need Poisson's distribution? Poisson's distribution is used in cases where the chances of any individual event being a success is very small. The distribution is used to describe the behavior of rare events. For example, the number of defective screws per box of 5,000 screws, the number of printing mistakes in each page of the first proof of book, the number of air accidents in India in 1 year, which is, if you see, a lot, but yeah, and also the occurrence of numbers of scratches on a sheet of glass. Now we will discuss some uses of poisons distribution in pharmaceutical industry. Control limits for number of tablets rejected from an online metal detector during tablet compression cycle. Microbial counts in raw materials, products, and water for pharmaceutical use. Control limits for numbers of containers rejected from visual inspection of sterile production batches. Alert limits of microbial levels in clean room environment. Release limits for microbial counts in non sterile products. Now, my friend Jayesh is going to explain the rest.
Here, Poisson distribution formula. The probability mass function of Poisson distribution is P of x equal to k equal to e raised to minus lambda raised to k and upon k factorial, where here the parameter is given by example the number of books sold per week. Here you can see the number of book is the ratio of the Poisson distribution. Now, condition under which Poisson distribution is used. The random variable x should be discrete. A dichotomy exists that happening of the event must be two alternatives such as success and failure. Applicable is those cases where the number of trials n is very large and the probability of success p is very small, but the mean np equal to m is finite. Statistical independence is assumed.
नहीं.
Characteristics of Poisson distribution. Here, Poisson distribution is discrete distribution and it depends mainly on the value of the mean. The distribution is positively skewed to the left with the increase of the value of the mean m. The distribution shift to the right and the skew diminished.
Pause.
The remaining part Sachin will explain.
So, guys, here we take one problem on Poisson distribution, and next, the conclusion is we can say that the Poisson distribution is useful in rare events where the probability of success p is very small and probability of failure very large, and value of n is very large.